The deployment of 5G networks is an ongoing process, as more and more features are introduced to accommodate the increasing capacity requirements for digital networks. The capacity of a cellular network is limited, among other things, by the available amount of radio resources. The amount of other data traffic in the network directly affects the quality of service that can be guaranteed for a specific service. This can become a problem if critical services rely on cellular networks to function. In the case of the 5G HEART project, smart junction and paramedic support are examples of such critical services. An overloaded network will result in packet loss and overall unstable connection, which in turn causes service interruptions. By introducing 5G standalone slicing, the radio resources of the network can be directly controlled. Slicing is used to create multiple virtual networks within a given physical network. Slicing can serve different goals, but in the 5G HEART project, one of the most important goals is the tailoring and guaranteeing of quality of service and network capacity for specific groups of services. Mechanisms such as configurable priorities between network slices are used to have direct control over the radio resource allocation between slices and to respect the quality of service requirements of the critical services. By using priority slices for the critical services from the transport and healthcare verticals, the network can guarantee the required resources for the application that is responsible for the communication from the ambulance to the traffic lights for a safe and prioritized passing of an intersection. Simultaneously, the network can guarantee the required network resources for the application that is responsible for transmitting the video feed from the ambulance towards the Chief Medical Officer for remote consultation. Even in situations where the network is overloaded due to a very high number of users, slicing guarantees the quality of service for the critical services. Using packet inspection tools, we can analyze the impact of slicing on the data throughput at the 5G network level. Here, we compare a network setup with no slicing to a network setup which has slicing configured and enabled. Without slicing enabled, the time-critical vehicle traffic is pushed down by the general internet traffic on the same network. We can conclude that by utilizing 5G standalone slicing, the network can guarantee quality of service for critical services. Priority slicing allows for direct control over the network's radio resources and ensures that the critical services always have the required resources available to them.